For fiber optic estimation guidance, several resources are available. Firstly, consider Building Industry Consulting Service International, known as BICSI, at bixi.org. Secondly, the Fiber Optics Association .org provides valuable information. Thirdly, the National Fiber Optic Engineers Conference .com can also be helpful. Fourthly, the Telecommunications Industry Association .org is another potential resource. Several estimating books are available on fiber optics. One is the Fiber Optic Cabling Manual by Charles Miller and Lee Belanger. Another option is Fiber Optics for Installers and Technicians by Jeffrey Bober. A third book is the Fiber Optic Installer's Handbook by George Holzner. A fourth choice could be the Fiber Optic Reference Guide by Michael Penner. Finally, the BICSI Installer's Guide to Fiber Optics is another resource. When estimating fiber optic projects, several tips can improve accuracy. The first step is to gather accurate project requirements. This includes determining the type of fiber, the cable length, the termination points, and any special requirements. The second step is to research and benchmark industry rates. Consult with experienced fiber optic contractors or industry associations to obtain unit prices. The third step is to consider labor costs. Factor in the time and resources required for installation, testing, and termination. The fourth step is to include materials. Estimate the cost of fiber cable, connectors, termination kits, and other necessary materials. The fifth step is to account for contingencies. Allow for unexpected expenses or delays. The sixth step is to break down the estimate by unit prices. Clearly identify the price per unit, for example, per meter of cable or per termination, for easier comparison and justification. Finally, carefully review the estimate and make adjustments as needed to ensure accuracy and competitiveness. To elaborate on gathering accurate project requirements, it's essential to have a clear understanding of the project scope. This involves not only knowing the distance the fiber cable needs to span, but also the environment it will be installed in. Will it be indoors, outdoors, underground, or aerial? Each of these environments will influence the type of cable needed and the installation methods employed. For example, an outdoor cable might require additional shielding and weatherproofing compared to an indoor cable. The type of fiber itself is also crucial. Single-mode fiber is typically used for long-distance transmissions, while multi-mode fiber is suitable for shorter distances. Choice depends on the bandwidth requirements and the distance the signal needs to travel. Termination points refer to where the fiber cable will be connected to equipment. This could be patch panels, switches, or other devices. Understanding the type of connectors needed at these termination points is essential for accurate material estimation. Special requirements might include specific industry standards or certifications that the installation needs to meet. For instance, some projects might require compliance with specific building codes or regulations. Moving on to researching and benchmarking industry rates, this involves understanding the prevailing market prices for fiber optic installation services. Consulting with experienced contractors can provide valuable insights into the typical costs associated with different types of installation. Industry associations like BICSI can also offer resources and data on industry benchmarks. It's important to consider that rates can vary depending on the geographic location, the complexity of the project, and the availability of skilled labor. Analyzing past projects and comparing bids from different contractors can also help establish a reasonable price range. When considering labor costs, it's important to account for all the tasks involved in the installation process. This includes not only the actual installation of the cable, but also the preparation work, such as pulling permits, surveying the site, and preparing the cable pathways. Testing and certification of the installed fiber is also a significant labor component. This involves using specialized equipment to verify the performance of the fiber and ensure that it meets industry standards. Don't forget to factor in the time required for project management and coordination. Larger projects might require a dedicated project manager to oversee the installation and ensure that it stays on schedule and within budget. When including materials, a detailed bill of materials is essential for accurate cost estimation. They should include not only the fiber cable itself, but also all the connectors, patch panels, enclosures, and other hardware needed for the installation. The cost of the fiber cable will depend on the type of fiber, the cable construction, and the quantity purchased. Connectors can also vary in price depending on the type and quality. Don't forget to include consumables like cable ties, labels, and cleaning supplies in the material estimate. Accounting for contingencies is a crucial step in any estimating process. Unexpected expenses can arise from a variety of sources, such as unforeseen site conditions, delays in material delivery, or changes in project requirements. A contingency buffer of 5 to 10% of the total project cost is generally recommended to cover these uncertainties. The specific amount of the contingency will depend on the complexity of the project and the level of risk involved. Breaking down the estimate by unit prices allows for a more transparent and understandable cost breakdown. This involves assigning a price to each component of the installation, such as per meter of cable installed, per connector terminated, or per hour of labor. Unit prices make it easier to compare bids from different contractors and to justify the costs to the client. They also allow for easier tracking of project expenses and cost control. Reviewing and adjusting the estimate is the final step in the estimating process. This involves carefully scrutinizing all the assumptions and calculations to ensure that they are accurate and reasonable. It's also important to consider any potential risks or opportunities that could affect the project cost. Make sure to factor in any discounts or rebates that might be available from suppliers or manufacturers. Finally, compare the estimate to similar projects to ensure that it is competitive and realistic. By following these tips, you can improve the accuracy and effectiveness of your fiber optic estimating process. Remember to always gather accurate project requirements, research industry rates, consider labor and material costs, account for contingencies, break down the estimate by unit prices, and carefully review and adjust the estimate as needed. Doing so, the process is much more reliable. Additional considerations in fiber optic estimating involve understanding the different types of fiber optic cables and their applications. Single-mode fiber is characterized by a small core diameter, allowing only one mode of light to propagate. This results in minimal signal dispersion and attenuation, making it suitable for long-distance, high-bandwidth applications such as telecommunications and internet backbones. Multimode fiber, on the other hand, has a larger core diameter, allowing multiple modes of light to propagate. This leads to higher signal dispersion and attenuation, limiting its use to shorter distances and lower bandwidth applications like local area networks and data centers. The choice between single-mode and multimode fiber depends on factors such as distance, bandwidth requirements, and cost. Single-mode fiber typically requires more expensive lasers and connectors, while multimode fiber is more cost-effective for shorter distances. Another important aspect is the cable construction. Fiber optic cables can be either loose tube or tight buffered. Loose tube cables have the fibers loosely contained within a protective tube, filled with gel or other materials to protect against moisture and environmental factors. These cables are typically used for outdoor applications where they are exposed to harsh conditions. Tight buffered cables, on the other hand, have the fibers tightly buffered with a protective coating, providing greater mechanical strength and flexibility. These cables are commonly used for indoor applications where they need to be routed through tight spaces. The selection of cable construction depends on the application and the environmental conditions. In addition to the fiber and cable, connectors are also a critical component of fiber optic systems. Connectors are used to terminate the fiber cable and connect it to equipment. There are various types of fiber optic connectors, each with its own characteristics and performance. Some common types include SC, LC, SENT, and MTP/MPO connectors. SC connectors are a push-pull type connector that is widely used in telecommunications and data centers. LC connectors are a smaller form factor connector that is also commonly used in data centers and high-density applications. SD connectors are a bayonet-style connector that is commonly used in older fiber optic systems. MTP/MPO connectors are multi-fiber connectors that can connect multiple fibers at once, making them suitable for high-bandwidth applications. The choice of connector depends on the equipment being used and the performance requirements of the system. Furthermore, testing and certification are essential steps in any fiber optic installation. Testing involves using specialized equipment to verify the performance of the fiber and ensure that it meets industry standards. This includes measuring the optical power, attenuation, and return loss of the fiber. Certification involves documenting the testing results and verifying that the installation meets the required specifications. Proper testing and certification are crucial for ensuring the reliability and performance of the fiber optic system. Other factors to consider in fiber optic estimating include the availability of skilled labor, the complexity of the project, and the geographic location. Skilled fiber optic technicians are in high demand, and their availability can impact the project schedule and cost. Complex projects with challenging installation requirements may require specialized equipment and expertise, which can increase the cost. The geographic location can also affect the cost, as labor rates and material prices can vary depending on the region. By taking all of these factors into consideration, you can develop a more accurate and reliable estimate for your fiber optic projects. When breaking down the estimate by unit prices, consider the different components of the installation and assign a price to each one. For example, you can assign a price per meter of cable installed, a price per connector terminated, a price per patch panel installed, and a price per hour of labor. This will provide a detailed cost breakdown that can be easily understood and justified. Unit prices can also be used to track project expenses and control costs. By comparing the actual cost to the estimated unit prices, you can identify any variances and take corrective action as needed. This will help ensure that the project stays on budget and within the agreed-upon scope. Also remember that accurate estimating is crucial for the success of any fiber optic project. By following the tips and guidelines discussed here, you can improve the accuracy and reliability of your estimates and increase your chances of winning bids and completing projects profitably. Finally, always stay up to date on the latest industry trends and technologies. The fiber optic industry is constantly evolving, and new products and techniques are being developed all the time. By staying informed, you can ensure that you are using the best possible methods and materials for your projects. In addition to the factors mentioned earlier, several other aspects can influence the cost of a fiber optic project. Permit costs, for example, can vary significantly depending on the location and the scope of the work. Obtaining the necessary permits can also add to the project timeline. Another consideration is the need for specialized equipment such as fusion splicers, optical time domain reflectometers, or cable pulling equipment. Renting or purchasing this equipment can add to the overall cost. The method of installation can also impact the cost. For example, aerial installations typically require different equipment and techniques than underground installations. The presence of existing infrastructure, such as underground utilities or overhead power lines, can also add to the complexity and cost of the project. Another factor to consider is the potential for rework or repairs. Damage to the fiber cable or connectors during installation can require costly repairs and delays. Proper handling and installation techniques can minimize the risk of damage. Also, documentation is essential for any fiber optic project. This includes detailed drawings, test results, and as-built documentation. Proper documentation can help with future maintenance and troubleshooting. Furthermore, safety should always be a top priority on any fiber optic project. Proper safety procedures and equipment should be used to protect workers from hazards such as electrical shock, falls, and eye injuries. The cost of safety equipment and training should be included in the estimate. Finally, communication is key to a successful fiber optic project. Clear and frequent communication with the client, the project team, and any subcontractors can help prevent misunderstandings and ensure that the project stays on track. By considering all of these factors, you can develop a more comprehensive and accurate estimate for your fiber optic projects. Remember to always gather accurate project requirements, research industry rates, consider labor and material costs, account for contingencies, break down the estimate by unit prices, and carefully review and adjust the estimate as needed. Doing so ensures the process is much more streamlined. To further elaborate on the topic of labor costs, consider the skill level required for different tasks. Fiber optic splicing, for example, requires highly skilled technicians with specialized training and experience. The cost of these technicians will be higher than the cost of general labor hours. The time required for each task can also vary depending on the complexity of the project and the experience of the technicians. It is important to accurately estimate the time required for each task to ensure that the labor costs are accurate. The location of the project can also affect labor costs. Labor rates can vary depending on the geographic location and the local market conditions. In addition to the direct labor costs, it is also important to consider the indirect labor costs such as payroll taxes, insurance, and benefits. These costs can add a significant percentage to the overall labor costs. Also, when estimating material costs, it is important to consider the quantity discounts that may be available from suppliers. Purchasing materials in bulk can often result in significant savings. The lead time for materials can also affect the project schedule and cost. If materials are not readily available, it can delay the project and increase the overall cost. It is important to factor in the lead time for materials when developing the project schedule. The quality of the materials can also affect the project cost. Higher quality materials may be more expensive, but they can also provide better performance and durability, which can reduce the need for future repairs or replacements. Moreover, when accounting for contingencies, it is important to consider the potential risks associated with the project. Some projects may be more risky than others, and the contingency should be adjusted accordingly. The contingency should be used to cover unexpected expenses, such as unforeseen site conditions, changes in project requirements, or delays in material delivery. The contingency should not be used to cover errors or omissions in the estimate. And when reviewing and adjusting the estimate, it is important to involve all stakeholders in the process. This includes the client, the project team, and any subcontractors. By involving all stakeholders, you can ensure that the estimate is accurate and realistic. The estimate should be reviewed and adjusted periodically throughout the project to reflect any changes in the project scope or conditions. By following these guidelines, you can develop a more accurate and reliable estimate for your fiber optic projects and increase your chances of success. Accurate estimating involves understanding the nuances of fiber optic technology, installation practices, and cost factors. It requires a thorough assessment of project requirements, meticulous attention to detail, and effective communication with all stakeholders. Always strive to improve estimating skills and stay informed about the latest industry trends and technologies. By mastering the art of fiber optic estimating, one can gain a competitive advantage and deliver successful projects that meet the needs of the client. The ability to accurately estimate project costs is essential for profitability and customer satisfaction. Estimating is not merely a guessing game, it is a systematic process that involves gathering data, analyzing information, and making informed judgments. A well-prepared estimate can serve as a roadmap for the project, guiding decision-making and ensuring that resources are allocated effectively. Conversely, a poorly prepared estimate can lead to cost overruns, delays, and disputes. So, invest the time and effort needed to develop accurate and reliable estimates for your fiber optic projects. By doing so, you can enhance your reputation, build strong relationships with clients, and achieve long-term success in the fiber optic industry. Always remember that accurate estimating is a continuous process that requires ongoing learning and improvement. Embrace the challenges and opportunities that come with each project, and strive to deliver estimates that are both competitive and profitable.